This video, we're going to talk about 10.2 Objective 1, where we define and describe concepts related to two-way tables and chi-squared tests. What is a two-way table and what are the entries in its cells? A two-way table is a table where the data are categorized with two variables. Which is that one right there. And the entries in the table's cells are observed frequencies. That one right there. Explain what we mean by the observed frequency and expected frequency for each cell in a two-way table. What notation is used for the expected and observed frequencies, and how do we calculate expected frequencies? The observed frequency is the actual frequency, and the expected frequency is what is expected if the null hypothesis is true. Observed frequencies are denoted by O, and expected frequencies are denoted by E. Expected frequencies are calculated using the expression row total times column total over grand total. There's a video for you to watch here about the relationships among key components in a test of independence. But let's go ahead and answer this question. Which of the following is incorrect for a test of independence? And that would be if the chi-squared statistic is large and the p-value is large. The chi-squared distribution looks kind of like this. So if we have a large chi-squared value, we're going to have a small amount in the tail. If we have a small chi-squared value, we're going to have a large amount in the tail. We're not going to have a large chi-squared value with a large p-value, which would be the area in the tail. Which of the following suggests that in a test for independence, the two variables appear to be dependent? So that's going to be if the chi-squared test statistic is large and the p-value is small. And which one best describes the test for independence in which all the observed values O are very close to the corresponding expected values E? That would be that the chi-squared statistic is small and the p-value is large, which is C. So the idea here, if we were doing a hypothesis test, remember that if the p-value is smaller than alpha, we're rejecting the null hypothesis. So the null hypothesis here is going to test for independence, and the alternate to that is going to be dependence. So when the p-value is small, there's going to be enough evidence to support that they are dependent, and our null hypothesis is that they are independent, which is what's going to happen when the p-value is large. All right, that's it for this video. We'll come back next time and talk about 10.2 Objective 2. See you for the next video.